Dear participant, you are asked to submit the feedback for this session and wait to up to 7:30 p.m. for the next session.
Ma'am, do we need to leave this session?
No, ma'am, no, ma'am.
Okay.
Yeah, it is recording.
Okay, thank you.
So hope I am audible.
Yes, sir, yes, sir.
Okay. Let me get the permission for sharing the screen.
Yes.
Hope my screen is visible and I am audible properly.
Yes, sir. Yes.
So if you allow, shall I start or shall I wait for a few more minutes or what?
No, sir, you will start, sir.
Yeah. Okay, then fine. So let me switch off the video first so that it will be bandwidth safe for me. First of all, thanks a lot to Madam for inviting me and giving me an opportunity to share my knowledge with a vast audience of so many people. So, as Madam has mentioned, I am a faculty at IIT Jammu now. So, basically from electrical department, and we are currently working on AI and application to different area of imaging and video processing. So today talk, I am supposed to discuss on something on you can say perjury, or you can say kind of deep fake, or you can say any kind of mischievous activity which is happening through internet. So we are trying to work on those area. And today talk, I am trying to concentrate on some of these areas. So starting with the content of deep fake detection, the aim of this topic or aim of choosing this talk is to describe you or give a idea about what exactly deepfake is and how we are working on deepfake detection and what is the importance of it, what are the challenges in deepfake, and definitely what kind of solutions available in the literature and how we are trying to address some of these challenges at IIT Jammu. So before going to the talk clearly, let me tell you. So Indian Institute of Technology Jammu is a place where I am working. So it is a newly established one of the 3G IIT. 3G IIT is to say that it's a third generation IIT. So it is established in the Jammu city in 2016, and we have a very beautiful campus of 400 acres, so where we have almost 11 departments are there, including electrical is one of the biggest department. So I am the head of the department and one of the associate professor in the department, who is taking care of mainly electrical and electrical components here. We have a very good lab, which we say it as underwater artificial intelligence lab. So we have a underwater lab also there. So which is of size, which is the largest in India even. So it's a 20 feet by 25 feet size underwater pool. So inside this, we have installed almost more than 70 to 80 sensors, which are mainly responsible for acquiring different type of underwater things. And whatever the things we are capturing, we are trying to use a artificial or AI technology to address the challenges, whatever they are in the existing scheme. So I welcome all of you. So if you have any idea to visit North India, you please definitely visit this IIT. So it is one of the premier IIT, you can say, in the third generation IIT. So in the first phase only we got 62 rank in NIRF. So one of the good IIT, you may say, in third generation quality. After the same, these are the contents of my talk. So I'm starting with the concept of deepfake, then effects of deepfake, then what are the clues usually people consider to detect deepfake, then different deepfake techniques, state-of-the-art techniques, and few of the technology what we have developed at IIT Jammu, which is from audio deepfake, video deepfake, and multimodal deepfake. And then we'll go for conclusions and some future works on which direction we are working currently now. So going to deepfake concept. So as the name implies, so it's a kind of fake things generated by AI or artificial intelligence, you can say. So we are using different AI technology in our regular life to generate different type of audio, video, and definitely images. So when you are saying deep fakes, this is to say that these are some synthetic media, or you can say synthetic videos, synthetic images, or synthetic audios, where a person in an existing image or video will be altered by AI tool, typically for some malicious or spread false information. So if someone want to spread a false information or malicious activity want to do, so what exactly they do is they go for creating some synthetic media by which it may be image, video, or you can say audio also, or combination of image, video, and audio, both three also possible. So in that case, if they are going for doing any malicious activity, we are saying it's a kind of deep fake. And definitely, as I already mentioned, deep fake refer to the content of audio, video, and text, and where the original features of the multimedia are manipulated. That means original audio, original video, original image, or one of them, all of them, if they are manipulated or they are changed by some AI tools, these are referred to as deep fake. So deep fakes are mainly created by some kind of generative adversarial network, which is a kind of popular deep learning algorithm, and autoencoders are the algorithm which are mainly used to generate these deep fakes. Now, giving one small example, so you might have seen the first phase, what you are saying, this is a kind of image. So this is an image. So this is the image of previous Prime Minister of UK. So we have considered this image as a source image. Source image is to say that the person image is considered to be manipulated, or you can say we are trying to consider some image source to be manipulated. Further, we are considering a driving video. So this is a you can say president of United States of America. So which video content we want to manipulate by using the face of UK Prime Minister. So here source is UK Prime Minister or previous UK Prime Minister, and we are considering a driving video of United States of America president. So from this, one deepfake video is generated. Sorry. Extremely sorry. Let me open this. I hope you can see my screen.
Yes, sir. Yes. Yes, sir. Yes.
You can see my video screen, right?
We can see only the slide.
Let me 1 second. Give me 1 second. One second. Give me. I have to stop my video and again give the access also. I hope you can see now. Are you able to see my video? Sorry. Hello. May I know if you can see my video?
Yes, sir.
So this is a video of Donald Trump, who is the previous president of United States of America. So we have considered this one is a target video, which is supposed to be mocked by a source video. You can say the face of UK Prime Minister or previous UK Prime Minister. So we have generated a video, something like this. You can see here, where we are trying to manipulate the content by using some source image. So here idea is that we want to spread a false information, or you can say someone want to create a false information. So by using this technology, we are trying to create a false media. And this type of media will be responsible for spending, or you can say spreading many false information among the people. So this concept is called mainly deepfakes. Now, there are very, or you can say vast amount of malicious activities happens due to this type of effects, or you can say due to this technology, there are several malicious activity happens due to, or you can say at a different part of the world, including political misinformation, where you can say that inflammatory statement created by someone. So let us assume if you want to spread that our prime minister is spreading some false information among the people of India. So this can be possible to be generated by a AI content. Similarly, you can manipulate the opinion also. So let us assume you want to say something, the same content can be manipulated with your voice also. So let us assume I am raising a voice against something, but my voice is manipulated and it is said that I am supporting that agenda. So that can also be done by AI or AI content media to spread the political misinformation. Exactly same way you can go for image abuse. So where damage of image in public or invade privacy. So you might have seen many a time many pornographic video of our favorite actor and actress come into picture by using deepfake technology. Also, people are creating. Similarly, content used for blackmailing, extortion, everything. So you can create many mails or letters, or you can say you can send messages to someone by using some AI generated content to blackmail or creating extortion to someone. Similarly, many agencies try to go for manipulating the stocks of their firm. So where financial fraud also happen due to this type of deepfake activity. Further, many companies are going for false statement, company performance. So they want to show that their company is doing profit, but actually their company is in very large amount of loss will be there. So that if they can show the companies in profit, so they can bring many investors to put money on their company. So this thing also possible, which mainly bring a impact in the stability in the market. So you can think of that the complete stock market will crash out due to a single company stocks which is showing profit in their name, whereas this is in huge loss. So one of them is, you might have heard of long back, Satyam is a company where similar thing happens. Now, these are few examples I will show. So you can see here, sorry. So this is a case actually, you can say. So this is an example where Jennifer Lawrence is a kind of actress, or you can say she's an actress in US or English media. So which voice is mainly imposed with Buscemi. So Buscemi is an actor and Jennifer Lawrence is an actress. So both voice and face are morphed actually. So this way they have created an interview of Jennifer Lawrence in the name of Buscemi. So you can see here. So here face of the person is Buscemi, where Jennifer Lawrence is the audio. So you can see here. So you can understand that here the complete video is manipulated by using some other person audio content. So you can see here, this is a very, oh, sorry. So this is another content. So this content happened in India only. So in Tamil Nadu election, Mr. Karunanidhi, who passed out long back, his video recording was animated or created by saying that he is alive to vote their party. This misinformation is created by some media. So this is one of the content where in Indian media, this content is used for some kind of activities. So this is another case where some negativity is spread against Obama long back by using AI technique only. So it is taking a bit time. Sorry for hard. So you can see here. So here is a case where Obama is saying against US election system. So this is a kind of activity also happened due to deepfake. So this is a media created artificially by a media house to spread the false information actually. So this is another case where you can see here uh, artificial video is created for a particular person. So he is not a Morgan Freeman, but his video is created by artificially creating some voice superimposed with his video, or you can say some of his face. Now, although there are many malicious activities that are happening throughout the world due to deepfake, there are several positive outcomes coming from deepfake technology, from which exactly this technology started actually, but later on people have started using for malicious activity, starting from entertainment, where many of high quality visual effects are created by this deepfake technology only. So you might have watched many of the movies in Indian cinemas, so which are mainly created by visual effects only. So these also contain many of the deepfake content, or you can say these are artificially generated by AI technology to bring the popularity. Similarly, many of the realistic portraying older one. So you can say that many of the movies you have watched where the actor or actress in the middle age or older age are shown with their content in the childhood pictures, or you can say childhood activities are shown, which are also created by deepfake technology. Similarly, in education and training also, many historical figures and fictional characters are created by AI technology or AI techniques. Similarly, many custom education video are created where actually no real teachers are there. Rather, these are provided with many, you can say, text of that or contents to the AI, where AI has generated a avatar to explain this thing. So these are also a possible of AI activity, or you can say deepfake activity. Similarly, design of molecule, or you can say potential trying for disease treatment also, people are using deepfake technology to see what are the effects of different drugs to different, you can say for molecules, effect to different disease treatment also done by AI technology like deepfake. Now, if you see the regional growth of AI, so the complete world is divided into 5 parts actually. So definitely Asia and Middle Asia, then Africa and Middle East, then Europe, then Latin America and North America. So if you see, the highest amount of deepfake happens in Asian region actually. So highest is reported in Philippines. So followed by second highest is Vietnam, and third highest is US, and fourth highest is Belgium, where maximum amount of deepfake happens. So you can see the map. So these are the latest report from 2024, where these are the reports says that how many amount of cases are reported every year for deepfake. So this says that the kind of deepfake activities what is spreading nowadays, it will potentially grow in future, and later it may impact a lot in economy, definitely personal image, definitely you can say many of the people will be largely affected by this. And this is a kind of cyber crime, or you can say this is a kind of cyber criminology. So where it is definitely required that one must take a severe action or any way to identify whether these are created or not created, so that in case of someone is uploading the media content in the internet, that can be detected properly. And if it is an artificially created media, then that can be objected there right away, so that false information cannot be spread on a particular person name. So this is the basic idea of my talk today. So where I am trying to say that deep fake is a kind of fraud mechanism. So we should know how to detect these deep fakes. And this is one of the important technology or different application of AI current days, where you are supposed to detect the deep fake contents. Now, if you are coming to deepfake technology to detect what are the deepfakes are there, or you can say if you want to detect an image or a video or any kind of audio media, whether there is a deepfake is there. So there are several clues to detect the deepfakes. So one of them is unnatural face expression. So you can see here. So the first line of the images you can see here. So it says that many a time a person when it is saying something or a person when explaining something, they have different way of expressing. So most of the people when they say something or they want to explain some activity, they are trying to give different expression. So you can see here fake media supposed to have a expression, unnatural facial expression is the criteria. So where you can say that this is can be a deep fake content. Similarly, you can say that awkward facial feature positioning. So you can see here that different person have a awkward facial posture or position. You can see here that different people are giving awkward facial features. So this is maybe a possibility case of or a second clue to say that a video contain a deepfake video. Similarly, many of the people who are in a video, they are giving unnatural eye and body movement. So you can see here, they have a unnatural eye or body movement. The fourth one you can see. So this is a kind of content which is maybe a deepfake content. Similarly, many of the time, deepfake technology consider teeth artificially. So you can see here, Barack Obama face, the teeth is not natural. So this is a kind of unnatural teeth. Reason is that none of the people face teeth are aligned in a horizontal direction. So you can see here, there is no variation in the teeth area. So this can be a deepfake content. Definitely, many of the deepfake content where clue can be considered by considering unnatural coloring. So you can see here, these are the face where the color is unnatural. So these contents are unnatural colors. So where artificially colors are used to create some person. So this is an unnatural coloring mechanism. So this is also can be considered as a clue to deepfake. So you can see here awkward looking or body posture. So you can see here, this is an awkward looking body posture. So where you can see clearly that person looks or body postures are not proper while they are talking. Similarly, many cases you find lack of emotions. So you can see here, so proper emotion is not there, or according to their the statement they're talking, their body emotions, or you can say posture. So these are the clues which mainly used to detect deepfakes. So complete literature, whatever you will see, these are the clue which is mainly used to detect deepfakes. So one is facial expression, then facial feature positioning, or you can say facial positions, then unnatural eye or body movement. So usually when a person lies, you'll find that they blink eye a lot. So this can be a one posture to say that these are unnatural. Similarly, teeth or artificially created teeth, artificially created colors, and definitely unnatural body posture are the condition which says that these may be a condition of deepfake will be there. And these are the clues used in the complete literature of deepfake to detect deepfake technology. Now, coming to when a person is going to manipulate a video or an image or an audio, so these are the criteria mainly used to manipulate. So first of all, generating deepfake is quite challenging. So both way deepfake has a profit and you can say balance will be there. So idea is that many of the deepfake technology are used, as I already mentioned, they are for entertainment purpose or creating drug molecules, or you can say many of the data where many of the information maybe you need to send in the education manner, or you can say to spread good information among the people. So mainly this type of deepfakes are created. But definitely when these deepfakes are created, that's supposed to be so much perfect so that other person should not able to identify. So that will be the first challenge. The first thing is that, as I already mentioned, that when deepfakes are created, then definitely these are supposed to be considered some clue to say that this is a deepfake. But when you are making the deepfake contents, it is always required that you should prepare the deepfake in such a way that people will not able to identify the deepfake. So first of the property is that it is called as attribute manipulation. So what exactly it says that only the region that is relevant to attribute is altered alone in order to change the facial appearance. So you can see here, this is a person face, so whose age is 0 to 30, or you can say a person age is within 30. Now, what exactly I wanted to do is, by using deepfake, I want to gender the same person in an old age, maybe 31 to 40 age, or 41 to 50 age, or 50 plus age. So you can see here, at a different age, the same person is represented by using AI technology. Now, what exactly we are doing? We are trying to alter the attribute of this person to change the facial appearance. So only person face appearance is changed by some AI technology. So you can see here, other than that, you can go for many such activity other than age change. Like you can wear eyeglass, you can remove eyeglass, you can touch the skin, or you can change the age, or you can even change the gender also of that person. So you can see here, this is a case where the person is having a baldness or a bangs, or you can say with eyebrow change. You can see here the color of the hair changes, started wearing glasses, or you can say blonde hair, mustache, pale skin. So just think, this has also an advantage that many a time we went to photo studio to capture our own picture. So where we want the photo studio person should adjust our picture so that we look handsome or we look good in the picture. But the same content can be used to manipulate or spread a misinformation. So just think, you have uploaded a picture of yours in marriage website who is in 0 to 30 age. Now someone has changed its characteristic and uploaded another place the same content with old age. Now just think how much the person will be affected by such kind of condition. So this is the challenge what exactly deepfake does. Now case is how to know whether this is a deepfake or not, so that the user who is seeing the picture, they can clearly identify this is a deepfake content and someone has purposefully uploaded it. We should not entertain, or you can say we should not consider this video. Now there are several algorithms are there for attribute manipulation, starting from GAN or generative adversarial network, autoencode, feature-based editing, or disentangled representation. So these are the techniques available in the literature for doing all these type of attribute manipulation. The second case is entire face synthesis. So you have seen this type of content in regular life also in many cases. So idea is that to create completely new realistic looking faces using deep learning models. So idea is that you are trying to use a completely new realistic looking face by using AI technology. Now what exactly it do is, whatever face is created, this actually not correspond to any real individual. So you can see here. So what exactly they have done? They have considered Angelina Jolie, the actress, you might be knowing, she is one of the beautiful actress. So they have morphed her face with another person. Now what they have done? They have created a new face which is not really belongs to any real individual, but rather they have considered entire face synthesis to create a new face. So this is a person face which is created artificially, which really doesn't exist, but this is coming from combination of several faces. So this is a kind of considered to be face synthesis application. So there are many algorithms are there, starting from style GAN. So style GAN is a kind of architecture which is from generative adversarial network, autoencoder, variational autoencoder, and diffusion models. So these are the models mainly used to create entire face synthesis application. Now, the third kind of thing is face swapping. So what exactly face swapping says that you have a particular person face, or you can say this is called as a target face. Now, one particular person video is available with you, where this one is the original face or original person video. Now, what I am doing is I am trying to consider a small cross section or small map or small mass on both images. So I am considering target face, this mask, and original face, this mask. So we are considering both pictures, we are considering a same size of cross-sectional view. Now what I will do, this person face, I will completely remove from here. So you can see here, I have removed the complete person face. Now after that, what I will do, this person face, which I have taken as a small cross-section, I am putting over this area. So which is of same size. Now you can see, you have created a new picture of the person who really never real life done anything such. So you can see here, this person never wear this kind of dress. But now you have created this type of person where this person is wearing this kind of dress. Now what you can do, you can go for face alignment, blending, and many post-processing to create different type of activity of this person. So what exactly you are doing? You are trying to swap the face of two pictures by maintaining the rest of the body and environment context to vary based on your choice. So what exactly you are doing? You are changing the content of picture by using face swapping process. So entire face synthesis, or you can say this is a wrong actually written here. This is actually a face swapping concept, or you can say this is face swapping. So this is mainly used for swapping the face of the person to spread also misinformation or wrong information also, you can say. The next process is face reenactment. So what exactly it says that it focusing on altering the facial expression of a person in a video. So what exactly you are doing? You are altering facial expression of a person inside the video, where a replacement of original face expression of the subject with facial expression of another person. So what we are doing is we are trying to put another person face expression on a source image. So you can see here. So this is a content actually. So he's Judge Bush. So what exactly happen is you can see person is changing its facial expression. Now exactly same way the things are implemented of where a old interview of our United States of America President Judge Bush expression is varied with the content of this person facial expression. So you can see here. So it also matches the audio also, and you can see the facial expression, the way person is giving the expression or eye gazing. So these all are recorded in the target video. So this is called as real-time reenactment, where you are trying to consider a source actor, so which is imposed on the target actor, create a video, so which is a real-time reenactment, or you can say reenactment of faces. So this way you can generate many of the videos changes. So you can think of that my expression will be imposed on one of your video, so I can change it, I can send it to many different places, so where I can say that you are doing the crime actually. So this is possible, and one of the biggest challenge current days. Now coming to the next part. So next part is lip syncing. So idea is that to generate a target face that appear authentic and synchronize with the given text or audio inputs. So what exactly do is you are trying to create a target face that appears authentic and synchronize with given text or audio input. So accurate lip movement and facial expression that align with the source video. So you can see here. So what exactly it is doing. So this is a actually video where one person is giving a presentation of their work. So which is mocked with Elon Musk video. So you can see here. So you can see here, Elon Musk never said anything like Livian and other thing, where the author is giving a presentation of their work in somewhere, so which is synced with the face of Elon Musk. So this is the content. So you can see here. So this is an artificial face created, whose lip synchronization and other thing is matched with the content of what exactly they want to say. So you can see here. So the left hand part you are seeing what? This is a video input. So which is unsynced with video. So what exactly it has been done is that some audio inputs are given. so that the complete video is seen to be a synced video. You can see here. So here, the left-hand side video is a unsynced video, whereas the right side video is a synced video. So left one side is an unsynced video and right side is a synced video. But case is the right-hand side video is more fake, or you can say it's a deep fake video which are generated artificially. So this is a case of lip syncing. So where lip of a person is synced with the authentic way to target face, so that one can understand that the same person has said all these things. Now, there are many technology which are used for such kind of algorithms, starting from rule-based model, WAV to lip, SyncNet, deep speech. So these are the algorithms which are used to create such lip syncing task. Now, second case is voice swapping. So what exactly do is, so this is a process of altering or replacing a person's voice in an audio with another person's voice. So what exactly we are doing? We are trying to alter or replace a person's voice in audio with another person's voice. So what exactly do is it completely change the voice characteristics while preserving the original speech content. So whatever original speech content will be there, that is preserved, but quality of voice or the transformation of the voice may occur on this kind of thing. So there are many algorithms are there, starting from deep voice 10, deep voice or wave to wake or GAN kind of algorithms are used for voice swapping. It's something like my voice is swapped with your voice or your voice is swapped with my voice. So where the content of the voice, or you can say, let us assume I am saying that Delhi is the capital of India. So I'm supposed to say the same content is supposed to be transformed in your voice. So India is the capital, Delhi is the capital of India. The same thing you are saying, but your voice will be used to represent it. So this type of things are called as voice swapping. So where original voice content will be same, only characteristic of voice will change so that it will be more seems to be authentic, like you are saying the same content. The next one is text to speech. So nowadays many media house coming. So you might have seen that nowadays they are going with AI generated bot to read the newspapers. So this is one of the best application in India already happened. So where AI generated avatar are used to read the news. Now, case is when all these things happen, or AI generated avatars are used for news reading. So what exactly they do is they are trying to consider a particular text, or you can say they are providing the text content of that news. So which is generated in a voice matter, or you can say text to speech conversion happens, and different sweet voice, or you can say variation of speech with frequency and loudness are considered to modulate the speech so that it will be better for hearing. Now, the same concept also can be used to clone the voice of a person also. So you can think of that one person is explaining or expressing the content very well, but his voice is not good to hear. So you can change or clone its voice also so that it will be good audible for everyone, whoever attending his classes. So that can be one case. Possible that if you want to create a prank against someone, so you can use also the same concept where the text you will provide to the AI so that the same person video will come with the AI content audio. So you can see here one example also. You can see here the person is creating AI content to talk with his mother. So the person is saying in an American accent to his mother. So the mother is able to understand that it's a American accent. Whether his son actually talking or not is verifying. So you can see here. So this is also a content of deepfake. So if you consider the complete architecture of deepfake, there are different deepfakes are there, starting with image and video deepfake and audio deepfake. So what we have considered till now, so deepfakes are generated by one of these applications or one of these media content. So either image or video deepfake, audio deepfake. So what I explained now, so these are the three approaches where synthesis or face synthesis will be there, or face replacement or swapping will be there, or face reenactment will be there. And similarly, we have understood that voice swapping or text-to-speech content are converted to create the media is possible. Now, further, when replacement happens, either face can be morphed or face can be swapped. And when we are coming with reenactment, head puppetry or lip sync will be there. So lips are synced or head will be synced. And similarly, for head puppetry, either position is supposed to be matched or gaze will be matched. So looking direction of eyes and eye movement will be considered as the one of the criteria to control the video. So these are the type of deepfakes usually occur in the market. So considering the current amount of deepfakes generated regularly, so these are the deepfake way people are considering to create the deepfakes. So one is image and video, another one is audio. So in audio part, you have voice swapping or text to speech, and image and video parts, you have synthesis or face replacement or face reenactment are there. So these are the 5 contents which are used for deepfake media creation. Now, once you have deepfake medias, now one of the important challenges is that how to detect if this is a deepfake or not. Now, there are several algorithms came also in the market to detect these deepfakes or deepfakes technology, whether used or not used in that content, you can detect using these softwares. Now, first thing is that when you are going for detection software, so InFeed, photo forensic or Amber video. So these are the software which are used to detect deepfake video. Further, when you are going for image or video content, Sensity AI, Deepware Scanner, Microsoft Video Authentication, and Deepfake O-Meter. So these are the software which are mainly used for image and video content. So these are AI powered content or AI powered software. So mainly developed for this kind of application. Similarly, there can be an audio deepfake only. So if there is only an audio deepfake, then open AI detection tools, Deepogram, and sensitivity AI. So these are the softwares which are used for audio deepfake detection. Now, all the software what I mentioned, these contains a lot of modules, and these modules are very costly. So when you want to use a deepfake content or any of your channel or any of your website or any of things what you are managing digitally through internet, if you want to use to know that whether any content is deepfake or not, you may need to buy any of these softwares or all of this software for your application. But definitely you have to pay a lot of amount of money for buying this software or using this software. Now, one of the solution to get a free available software, or you can say there are some softwares are there with a limited amount of module which are available freely. So one of them is face forensics. So mainly face synthesis or face replacement or face reenactment thing you can do. And video or InVid is a software, so which is mainly for video synthesis, or you can say video deepfake you can go for. TruePic is a picture-based deepfake detecting software. Fake Art Viewer, then photo forensic, voice deepfake detection. So these are some software which are freely available for use, but definitely it has some limitation, which are mainly not for universal application where you can use it for anything. But definitely if you are paying a price, you may get a better deepfake detection tool. Now, what exactly a challenge for designing a software? So why they are charging so much amount to get a deepfake detection? Now, as I already mentioned that these softwares are charging a large amount of money for deepfake detection. Definitely it has some specific property or specific idea or specific algorithms are used which are really costly to be paid for. Now, idea is that many of the detecting softwares, what exactly faces the challenge that every time new way of creating the deepfakes, or you can say editing the photos, videos, or audios, or synthesizing the video and audio happens to create the deepfakes. Now, previously, when people thought of deploying advanced technology for generating realistic image and video, they have only gone for skin, eye, and texture improvement. So you can see here. So previously, 2014, 15, and 16, people thought of going for only improved skin, eye, or texture improvement so that people will not able to identify whether it's a deepfake or not deepfake. But later on, evolution of this software happens and detection evasion is quite challenging. So what happened? People started using deploy multiple techniques to evade detection so that people are not able to identify whether there is a deepfake or not. So what they have done? They have gone for lip movement addiction. So exactly the way people saying or expressing the according to the text or according to the voice, they started going for lip movement variation. They started facial expression change. They also went for smooth transition in one frame to another, this face, video, and audio content. Now, further, these are extended to multimedia content. So you can see here 17, 18, 19, 20, 21, now till 24, people have gone with the latest technology of multimodal technology where spatial, temporal, and also voice consistency are used to seamlessly integrate both body, video, and audio content so that the complexity will be too high to exactly identify if there is a deepfake or not. And this creates a challenge that any of the software developed, this will face a challenge how to detect the deepfake. And this is the main reason why people are charging a large amount of money for this deepfake software. Now, if you consider the complete literature, so complete literature is divided into 5 different types for deepfake detection. One is spatial artifacts, temporal inconsistency, audio-visual inconsistency, biological signal analysis or psychological signal analysis, and spatiotemporal inconsistency. So first one is spatial artifacts. So what exactly it says that when a person creates a deepfake, it exactly exhibits many blurry and distorted edges around the facial features. So during the movement of their face, if it is an artificially generated AI content, then definitely it will create some blurriness. So you can see here, these are the some blurriness you will get in the face. So these are mainly a spatial artifacts. Now, this mismatched lighting and overly smooth, unrealistic skin texture are mainly spatial artifacts which can be used to say that this is a deepfake. So deepfake detection softwares mainly consider one of the main criteria as spatial artifacts. So where they are seeing if there is any blurry, distorted edge or miss of unrealistic feature or overly smooth areas are there in the face region of a person. Now, if it is there, so it is called as spatial artifacts, and these are a sign of there is a deepfake. The second one is temporal inconsistency. So what exactly temporal inconsistency says that how will the manipulated face or body movement align with the natural motions pattern. So if you are considering a person video, so you can see here, this is the different frames generated from the person video. So you can see here, when a person is saying something or moving its face to different direction, our body movement usually create natural motions. So if I am moving from one direction to other direction, my natural motion will try to give you different way of alignment of different body portion. So you can see here, however, this video where deepfake is there, although the person expression changes, so you can see here, person expression changes in all video, but its eyebrow movement definitely not changing. So you can see here, all the frames, its eyebrow motion is constant. So this says that there is a unnatural motion is there. So this is a temporal inconsistency which doubts that whether this video is created by a deepfake content or AI content, which is not natural. So this is called as temporal inconsistency. So this says that face and body movement supposed to align with natural motion of the person. If there is a natural motion of the person is there, then body alignment or body different part, face and body movement is supposed to align with its body. So this is a case, what exactly is called as temporal inconsistency. The third thing is biological signs. So usually when a person lie, we usually go for large amount of eye blinking. Now it may possible that many a time it happens that if a person face is depict, although the person is saying something, its blinking pattern will change. So if I am saying something, if I'm lying, if I'm saying something, if I'm serious, if I'm angry, the eye gaze, or you can say my eye blinking pattern will definitely go for changing. Now, if it is not changing natural way, like a person is lying, it should blink more. If it is stressed, it's supposed to blink more. If it is happy, it's supposed to blink less. If a person is not in a good way of expressing, then eye pattern or eye blinking pattern will be unnatural. Now, if you can spot this thing, then you can identify whether it's a kind of deepfake or not. Further, many a time it happens that eye lower region, or you can say the facial skin color, is one of the criteria to monitor the heartbeat. So if a person is saying something or is in a serious mood, its color will be different. When face is very in happy mood, its skin color will be different, or facial skin color will be different, or facial skin texture will be different. And you can consider that these are the criteria which are mainly source of natural blood flow in a human body. So now many people, what they have done, they have created a technology where they can easily identify that if a person is in serious mood, but its skin color is not changing, then definitely it's a kind of deepfake content. So you can see here, this is a kind of example actually. So you can see here, when a natural gaze will be there, the eye movement will be in a either intersecting or converging direction, or in case of parallel direction, or you can say in the same direction. Whereas if you have a fake gaze will be there, the eye movement will be unnatural, where it will be trying to diverge or trying to dissect with each other, or one is going straight direction, another will going in another direction. So this is one of the challenge you will face in case of eye gaze or biological signal sign. The next way is spatiotemporal inconsistency, where there will be inconsistency, facial movement will be there. So what exactly it says that the facial expression or head pose between frames breaking a smooth transition. So that means when a person is seeing, its a movement of face, movement of head is supposed to first follow a smooth transition actually. So if it is not following, it's a inconsistent facial movement, you can say. Definitely blinking or gaze inconsistency. Every person in a serious mood or a happy mood, in a stress mood, or you can say in a sad mood, or you can say different way of expressing the eye blinking pattern also vary if you are going for spatial temporal inconsistency, where a particular frame you are considering that eye movement is like this, and temporal consistency you are seeing how many times eye blinks in a second. So that can be a measure to say that whether it's mocked or not. Similarly, texture flicking. So as I mentioned already, when a person is in serious mood, it will be the face region will have more pigmented, and whereas if it's a happy mood or any kind of jolly mood, the face region will be smooth textured, or you can say smooth region will be there. So that can be a criteria to say that there will be spatiotemporal inconsistency is there. Definitely, if a video is mocked or deepfaked, then the direction of light and shadow will also change. So you might be knowing the shadow will appear on the direction of light only. So if the direction of light and shadow are different, so you can say this is a spatiotemporal inconsistency or deepfake will be there. Similarly, audio-visual mismatch will be there. So if a person audio and video both are not synced, or you can say lip are not synced, so you can say this is a spatiotemporal inconsistency and there is a deepfake will be there. Similarly, unrealistic motion flow. So you can see that there will be abnormal or erratic transition in body movement will be there. So which will say that this is also a spatiotemporal inconsistency to say that there is a deepfake will be there. So this is the example you can see here. So in particular mouth region or lip region, you can see there is a spatial region or spatial transition is there. Or you can say spatially, if you say there is a contextual smoothing is there. Whereas if you see in the temporal direction, the motion of the lip is not sync with each other. Or you can say there is no smooth transition of lip syncing is there. So this create a challenge to say that this is a deepfake content, and this can be considered as one criteria to detect the deepfake. Next one is audio-visual inconsistency. So you can see here there is no synchronization between audio and visual component. You can see here. So this is the example actually. So this is a content where North Korean president is saying about the democracy content. So, or democracy is good, they are saying. So this is a misinformation they might have trading with someone. So this is a kind of content you can see here. So here the audio and video leaf pattern movement is not synced properly. So you can see, and this can be considered as a clue to say that there is a deepfake is there. So this is the kind of video also created for lip sync mismatch, or you can say facial gesture and expression mismatch, or time misalignment, or background noise artifacts also there. So this says that in background some other things are happening, but here there is nothing in the background. So this also says that this is a audiovisual inconsistency is there. Now, coming to the deepfake market, actually, or you can say deepfake literature, what are the databases are used, or you can say how the database are used. So if you see the complete content of deepfake, 30% of the literature using only one database to verification is face forensic. And please note, this is a kind of video database. Similarly, 16% are using DFT database and 23% are using DF database and 9% is using the DFT database. And please note, these are only, you can say, video database, whereas only 3% literature consider multimedia database for checking their algorithm. So only multimedia database is fake AV celebrity. So this is a kind of database which is available in the literature for testing the multimedia content. Or another one is there, sorry, I forgot to mention, 5% of the content also using this multimodal database, which is DFT IMIT. So these are the two database, fake AB celebrity and DFT IMIT. So these are the two databases are used for multimedia content, whereas other databases are for video deepfake detection. Now coming to little, anyone saying anything? Okay, maybe someone has switched on their audio. So coming to the databases, so there are first database which is maximum use is face forensic plus dataset. So as I mentioned already, so this database contain pristine image. Pristine means original raw images, which is correct real images. It's deepfake content. So these deepfakes are specially designed using encoder. Actually, two encoders are used to map with each other to create the deepfakes. There is a database called as face-to-face, so which is used to reenactment or facial reenactment process is used. Face swap application is there also in this database where 3D template model is fitted to create the face swap. The natural texture are added to different person. So this database contain these 5 different type of challenges to be considered for deepfake detection. So if you go for testing your algorithm, so you may be using one of these database. Next is DFDC and DFTIMIT. So which is, I already mentioned, is a multimedia database. So in case of DFTIMIT, face swap GAN is used, whereas DFDC, so deepfake is there, where morphable face swapping is there, and tile GAN is used for face reenactment also. So these are the database also there. Now there is a fake AV celebrity database is there. I already mentioned. I will be happy if you can mute the person who is saying. Extremely sorry.
Hello, Vidya ma'am, please mute your audio.
In fake celebrity database, so sorry. So I have some video actually. So these are the real video actually. So you can see here.
Badri sir, you are the host more than you will make a video.
Okay, I'm muting all actually. So going with the second video, which is a real video fake audio. Video is real, but audio is fake. So this is a kind of fake audio is used. So this is a fake video and real audio. So here video is mocked and audio is same. And this is a content with fake video and fake audio. Both are fake. So this is a kind of database which is called as fake AB celebrity database, where manipulation method used for fake AB celebrity database like Web2Leap, FaceSwap, GAN, SB2, TTS is used. Now, if you see all these applications where people are using different kind of technology to detect the deepfakes, what exactly they are doing is they have a input video. They're extracting the video content, audio content. From the video content, they're extracting the face area, or you can say face regions, and definitely audio content. So they're extracting the face features, audio features, and feeding it to any kind of classification process to detect fake or real. Now, if you see the literature, so first I'm going for unimodal, or you can say visual deepfake or video deepfake. So video deepfake process starts with kind of PPG map, or you can say what they have done is from the skin color, they have tried to generate a PPG signal, or you can say biological signal they are created. Now, using different type of CNN algorithms, they try to detect what are the deepfake content. Now, idea is that with this, the deepfake detection accuracy improves. But definitely, when you are considering this kind of deepfake algorithms, biological signals are limits methods where effectiveness in cases means you cannot clearly distinguish that whether it's a really deepfake or not, because many distinguishable patterns may not be able to observe real life. So many process you may not able to get success. Eye blinking is considered in the next approach. So here high sensitivity, you are getting anomalies in eye blinking pattern. But definitely only eye behavior will not able to say that whether it's a deepfake or not. Then facial emotion or speech emotion recognition you can use. It's a simple architecture, but it's a biased model because it will go for audio part only. Third case, consider spatial gaze inconsistency, where what exactly you are doing? You are trying to consider a face region of a person to detect whether there is a eye blinking pattern or gaze is supposed to give you that whether it's a deepfake or not. But it's a very complex architecture and unimodal. Only video you can consider. Then people came with a two-stream network where video is considered with different platform media are considered, and they try to identify whether there is a deepfake or not. But usually it is limited by adaptability to future deepfake detecting, because many a time different content comes to market, so it cannot cope with those content. So people thought of going for audio deepfake also happen. So what people have done is they try to consider multi-branch architecture where different features of the audio are extracted, and these audios are fed or you can say kept inside one of the CNN architecture or deep learning architecture to detect whether there is a deepfake or not. So they have considered different features. So robustness is that they are very robust feature, but definitely they have different complexity, latency, and limited by spatial application only. So this is one of the challenge in audio deepfake. Now people thought of going for multimodal case. So what exactly the way? They tried to consider detailed feature extraction technique where different modality like audio and video are considered to find out the features out of the video. And these features are usually considered to maintain the harmony, and you can say, they're unable to maintain the harmony. And that's why many a time this type of architecture are failed to detect the real deepfakes. Now, some of the algorithms we have tried to develop. So I will go 4-5 architecture which are developed by our labs for detection process. So this is one of them. So what exactly we have done? We tried to go for 3 different features. One is gaze analysis model, one is texture analysis model, and attribute analysis model. So what we have done is we tried to extract a gaze feature, texture feature, and attribute feature. And these gaze, texture, and attribute features are filled with both spatial attention and temporal attention using a transformer network, and which will say whether it's a true or a deepfake video. So this is the idea. So first what we have done, for gaze analysis, we try to consider the pitch and ear angles. So what we have done, we try to extract the face region of the person first. From there, we try to extract the eye portion of the person or eye portion in the face area. Particularly around the eye region, we try to consider different features which are representing the eye constituent parts. And these feature positions are mainly used to find out the gaze or eye directional movement or blinking pattern. Similarly, for texture analysis, we have considered one texture extraction software which is called as a Race2Net 101. So where skin textures are extracted, and these skin textures are considered as one of the feature. For attribute feature, so what we are doing is we are trying to consider a Resonate 34 network over the face region of the person. Now we found 3 different features out of it: gaze analysis model, texture analysis model, and attribute analysis model. So we are getting gaze feature, texture feature, and facial attribute feature. Now what we are doing is we are going for a spatial attention. So where we are trying to find out what are the spatial distribution of human faces there. And temporal attention is used to find the temporal inconsistency in the video. Now using this inconsistency, we are using a fully connected layer to detect whether there is a deepfake or not. If there is a deepfake is there, we are saying if this content is deepfake and it's a very real, we are allowing it to be used. This is what exactly our comparison model is saying. So you can see here, the proposed algorithm is giving quite a better accuracy as compared to most of the existing model what is available in the literature. Starting from 2022 to 23 models we are trying to give it. Although we compared with many algorithms, here we have presented only with a few algorithms for legend purpose. Now, second model, we are considering a video defect detection model. So what exactly we are doing is we are trying to consider a real face and a fake face, or you can say real video and fake video. From real video, we are trying to consider the distribution of color in the different frames. And we are considering different channels R, G, and P to represent a red channel PPG, green channel PPG, and blue channel PPG. And similarly, we have considered a C channel PPG, that is to say that prominence channel PPG. And we try to plot these signals, and we are seeing this is a PPG signal or biological signal. So there is a existing approach is there. So we have considered the same technology to plot the PPG signal from these facial regions. Now, using these PPG signals, we try to consider a signal transformation process. So where we are using a Fourier transform mechanism. So where we are using a frequency domain representation using FFT and short time Fourier transform technique to represent time frequency analysis of these features. And these features are fed to a fully connected layer classifier to classify whether this is a real or fake video. So considering this, so these are the complete outline of this algorithm. Not going on detail. So these are the results what we are getting. So we have tried to compare with a different model with a different data set. So you can see here. This is the UADFB data set, FF plus FF. So using fake up, face-to-face, face-to-face, face swap, deepfake, all. So you can see here, the proposed algorithm is giving quite better result on different data set with a different type of challenges we have considered to classify it. But definitely for page constraint, I have given only few algorithm, or you can say few results to represent here. The third model, what we have developed is a video deepfake detection model. So what we have done is, we have considered the video data of a particular person. That person is supplied with a gender, activity, and time. So that means whether it's a male or female voice, or it can be what kind of activity is going and what time of the day is there. So during the evening time, people are feeling tired, the way of expressing, and during the daytime, due to work pressure, their way of talking will be different. So what exactly we are doing? We are trying to feed this into a target detector model. So what exactly we are doing? We are trying to extract first the face region of the person. And then we are extracting eye tracker to finding the eye blinking pattern. Now, based on the eye blinking pattern, age, gender, activity, and time, we are trying to detect whether it's a real video or fake video in this context. So this is the complete algorithm going with the verification results. So this is the result what we are getting. So if you compare with the existing algorithm, most of the existing algorithm is giving an accuracy of 85.5, whereas the proposed approach is giving 87.5% accuracy. Now, similarly, we went for audio fake detection. So these are some algorithms. So what we are doing is, we are trying to consider different database where audio signals are there. So we are trying to add different type of noise to the data. So we have a noisy data, we have a real data. So what we are doing is, we are trying to extract resonate 50 features, or you can say we are trying to go for MFCC coefficient or male spectrogram frequency or male spectrogram feature out of it. On the male spectrogram feature, we are using a resonate 50 architecture to extract further feature. And these features are fed to a classifier by sorting the feature by a LDA algorithm, linear discriminant analysis, to select few feature. And these features are fed to different classifier like support vector machine, KNN, random forest, naive-based classifier to classify whether real or fake audio is there. So this is specially designed for audio classification. So this is the result what you are getting. So different measure we have considered: accuracy, precision, recall, F1 score, EFR. And we have considered support vector machine, random forest, naive-Bayes, KNN, different technology and proposed approach. So you can see the comparison. So this is giving quite a better result as compared to the existing technology you can see here. Now, next approach we are going with audio segment process. So what exactly we are doing is we are considering a segment of audio and we are dividing this audio into three different type classes: silence, breathing, and speech. After the same, we are considering these classes or these audio segments to be positional encoded and different encoding process for encoding. And further, the same signal is fed to a CNN algorithm to extract some specific feature and fused over here to be classified as a bona fide or fake audio. So what exactly we are doing? We are getting a sample audio signal. We are extracting LFCC coefficient, or you can say linear frequency septal coefficient. On that, we are using a GMM classifier to classify whether it's a what kind of audio segment is there, like breathing, talking, or silence. Now, once you are getting all this, we are considering different type of encoding process, like positional correlation encoding. We are considering RNN network. We are using CNN, and we are using transformer encoder to encode the signal or all three different type of audio segment into different type of encoding process. Now, what I mentioned here, there is a countermeasure baseline system where what exactly we are doing is we are considering the raw audio passed through a CNN network to create a specific feature. This all three feature fused with this one will be used to create a combination of feature pools. And these feature pools are fed to a classifier to classify whether it's a fake video or fake audio or real audio. And this is the result what we got. So with different algorithm, we are getting quite a better result as compared to the most of the existing technology. Now, other than that, we have also went for a multimodal spatiotemporal approach. So where both audio and video streams are used to classify. So what exactly we are doing is we are initially extracting the audio from the video. So audio and video part is separated. In the audio part, we are considering male spectrogram or MFCC coefficient, or you can say MFCC feature out of it. So similarly, for video part, what we are using a 3D resonate algorithm to find out 3D feature. And similarly, from the audio part, we are using MFCC coefficient and extracting a 2D CNN to extract more amount of feature. Now, after the same, we are using for temporal encoding process by LSTM, and further, we are classifying using some classification process. So you can see here, this is the complete architecture. We have some video frames. So what exactly we are doing is we are initially taking out the face region of the person. We are applying a 3D resonate 18 model to extract the features. Similarly, from the audio part, we are using a male spectrogram to extract the feature. On male spectrogram, we are using a 2D CNN algorithm to extract more amount of feature, or you can say more deeper feature. After that, we are using a LSTM algorithm to go for encoding process on both the part, in video part and audio part. Further, these features are concatenated and a fully connected layer is used to go for real or fake audio, or it may be possible that real video, real audio, real video, fake video, real audio, and fake video, fake audio possible. So these are the process we are following. Now we try to use different type of algorithm for comparison. So you can see here, this is the ROC curve of the result. So you can see here different accuracy of different techniques, how well it is detected. So this is a confusion matrix. These are the ROC curves. So this is the comparison with the existing technology. So you can see here, the proposed approach is giving quite better result on different categories. So these are wave to leave, phase swap, FS GAN, phase swap, SB2IT. So as compared to the existing technique with a different technology, you can see here, our accuracy is quite better. So going with the last slide of my talk. In conclusion, we have tried to use a different spatiotemporal contrastive multimodal framework for defect detection, leveraging intramodal and cross-modal forgery clues. We use contrastive learning also for feature across modality to capture effective nature of forgery cues. We also consider different modalities starting from audio and video to represent the defect. Further, if you see the future direction, the cross-modality gap is still now. Many positive pairs and separate negative pairs feature space are considered. Several modalities are yet to cover. Currently, the direction is going towards biomedical devices and biomedical direction also. And also it is going for popularity in the direction how to consider biomedical signal analysis also for representing or finding the defects. With this, that's all from my side. I welcome you all. If you have any question, please let me know.
Dear participants, you are welcome to ask your questions to Dr. Badri sir. Questions from participants, you are welcome to ask questions.
One of the participants posted the question in the chat.
Okay, so one question is that can you please comment on the evaluation method for deepfake as they looks very real in actual? So there is no evaluation method you can say. Rather, what are the classification process you are seeing? Whether its accuracy is high, if that is the process, then you can say it is evaluating whether your classifier is giving good accuracy or not. Other than that, there is no evaluation processes to say that deep fake or not. I don't think it's a kind of classification accuracy only says that whether it's a deep fake or not. See, if you can go for extracting more deeper feature, like as I mentioned that there are specific feature like eye blinking pattern, face color, face gaze direction, then if any other inconsistency like spatial, temporal, biological signals. So these are the only methods to say that these are defects. But there is no evaluation method. So evaluation method, we usually consider the classification accuracy or classification performance as the criteria to evaluate if they're giving good result or not.
Hello, sir.
Yes, please.
Sir, any future work in face morphing?
Sorry, your voice is getting disturbed in background, I guess.
Sir, face morphing future work, sir.
Face morphing, as I mentioned, face reenactment is the one of the criteria actually people are coming with. So what exactly happens is the way your body posture, movement, and other thing like variation of your facial expression, all these are varying with content of the video. So this is one of the best challenge actually. Previously, people are thinking only for face swapping. Now, face reenactment is the only future approach, or you can say one of the challenge actually. So if you see most of the approach, they might not have got more than 80% accuracy actually. This is the one of the biggest challenge. Face reenactment you can consider as the one of the biggest challenge actually here in this area.
Okay, thank
Over
you,
to
sir.
you. Over.
Sir,
Yeah, please.
You can ask ma'am, then I will ask ma'am. Ambika ma'am, first you
I,
can ask.
sir,
Yeah, please.
sir, this is Ambika from Madurai. So my
Yeah.
question is not in this FDP. So I want to ask some details about your research center, underwater research center, because I am doing research in underwater image processing. Can I have
Okay.
some questions and can you share some ideas about this?
Okay. Uh, Means you want what are the areas on which we are working, or you want to know?
Underwater image processing.
Okay. So there are two challenges in which we are working. So one of them is you might have seen that in underwater case there is high disturbances in the images, or you can say the quality of image degrades due to decolorization, because once you are going depth inside the water, you will find that color component is losing. And second thing is that since you are having many blurry component, or you can say due to many suspended particle inside the water, the direction of light, or you can say uh, there will be scattering phenomena will occur in the image. And due to that, the quality of images degrades a lot. So this is one of the biggest challenge. So image enhancement can be one of the challenge. Second thing is that one of the biggest problem is that underwater object detection and tracking. So on which we are working for last maybe you can say last eight or no, I guess more than 10 years we are working on this area.
Okay.
So mainly way to find out how to preserve the object boundary inside the water, because underwater objects are quite blurry, distorted edges. Further, you can say color component is less. So when they're moving inside the water, how to preserve or find the exact shape of the object and position of the object. Now, different mechanisms are there, starting from you can say that you can use underwater sonar, underwater acoustic, you can use underwater imaging, and underwater ROV also. So we have all this facility in IIT Jammu. So we are working on this, and we have published a lot of work on this. You may go through our website and you can find out more details on this. Over to you.
Okay, sir. Sir, I have three questions in my mind. May I ask now?
Yes, sure.
Sir, in IIT Jammu, located in island region, and the underwater research center, despite its contrast to typical coastal landscape, could you
Yeah,
explain the reasoning behind establishing such a facility in this location? How
yeah.
does the
Let me tell you.
uh,
Previously, actually, we are in Goa, so we got a lot of funding from Goa actually.
okay,
Now, case is definitely kind of facility available in Goa for underwater is quite difficult. Then what we have done is we try to collaborate with the different places for our work, starting from NSTL in Vizag and
okay,
CFMRA, Center for Marine Research Institute in Trivandrum, then CFMRA Mumbai, and then Naval Board of India in again Vizag. And then we have collaborated with Bay of Bengal Chilka Developing Authority in Odisha. So what exactly we are doing is we are trying to give them few sensors, which are again from different projects. They
okay,
are collecting the data from us. So currently we are going with several projects actually on this. And a recent project is going with marine fish cage for fish monitoring in Indian Ocean. So where we have installed several cages inside the Indian Ocean, which are up to diameter of 20 feet and 30 feet. So where fish are there inside, and we are putting different cameras inside the water to capture the images. And definitely all the time we cannot deploy software or algorithm inside the water. So for initial testing, we have established a small lab where we are testing our model, but definitely deploying those things is supposed to be tested in the Indian Ocean. So what we have done is we have tried to put a network, so where we are collecting different data and doing our work in IIT Jammu only. That's the thing. Over to you.
okay, sir. Sir, one more question. I have noticed that compared to other domains, there are few institutes offering FDP training programs and opportunities for collaboration and internship. So I'm keen to learn more in this field. Does IIT Jammu provide any such opportunities for collaboration, internship, or professional development program in underwater research?
Yes,
Or
yes, many. We have done many programs on this, and I think many people are working with us, starting from many places, starting from different part of India, at different IITs, different NITs, and different private colleges, and definitely different universities in India are
okay,
collaborating with us for on this underwater and AI component. We are
okay,
open for collaboration.
okay,
Even if
sir.
you write to me also, I will definitely consider for collaborating. There's no doubt on it.
How can I approach you, sir?
You can write a directly mail to me.
Okay, sir. Thank you.
Thank you. And I have my number in my website also.
Yes,
So
I have seen, sir, just now because when you started the workshop, I keep on going on my mind apart from this deep fact. So that's why I asked question now.
you can directly call me. Actually, I initially thought of giving a talk on underwater, but madam told that
Sir,
best to
that's a
go for
problem, sir, because in south side, even though in IEEE Explore also, there is no more underwater research papers in from
because
India.
underwater research is a very new area actually. It is evolving, and you will
Okay.
find a lot of issue also publishing in this area. That is also true.
Okay.
But definitely it is very good area, evolving very fast now, and
Okay.
many people will appreciate the work you will do in underwater.
Thank you, sir.
And currently we have a group of almost 7 to 8 people who are working on underwater. So half of our group is working in underwater actually.
Okay, sir. Thank you very much for your information. So I will contact you later.
Sure, sure, sure.
Thank you.
Any other question if you have?
Sir,
Yeah, please.
one question posted in chat box, sir. After that, I will ask, sir. Sir?
I'm looking at this thing. I think one question came that uh,
With methods and algorithm
what
for
good
detecting.
algorithm to detect facial expression recognition? So I think I already mentioned that eye blinking gaze pattern or gaze recognition, one gaze feature extraction algorithm you can go for. And another thing is I mentioned that facial texture or facial pigment extraction algorithm, which will see that biological signal for facial expression. So these are the algorithm, or you can say PPG signal extraction for face. So these are the algorithms are used. Next question is with sir, I have a question just out of curiosity. With methods and algorithms for detecting deepfake videos, deepfake generation system will also keep improving. Possible both aspects keep improving each other. Will detection not come to dead end someday? Uh, there is no answer to it because nobody knows what will happen for deepfake videos. Definitely, very strong algorithms are now coming for deepfake generation, and it is really challenge. And this is the main thing that as quick as people are generating new deepfake videos, if your algorithm cannot detect it, then definitely this area will go on evolving. And it is required also that, like the way people are generating viruses and antiviruses are also there, which are trying to get the market by detecting these viruses. So exactly same concept only, because this market never ends. We are hearing from childhood that many viruses are generated or software viruses are generated long back, and people are generating going on anti-spamware, or you can say spam detection algorithm, or you can say antivirus software. So exactly same way that you are generating deepfakes and you are generating deepfake detection algorithm. It's like that. AI in electronics embedded systems. Now, electronics embedded system, I cannot say much, but definitely AI is coming with the edge devices. Now, many of the AI devices are coming with AI softwares. So those area, what kind of accelerator card or what kind of you can say hardware configuration supposed to be used. So this is quite challenging also. Kind of many uh, core, or you can say many processors with uh, many parallel operation you are supposed to do with AI. So these needs to be implemented with some specific hardwares. So I think that kind of things you can think of in electronics or AI edge devices. Other than that, I don't have much on embedded part, electronic embedded for AI. No, I really sorry, because those area are getting wider and they're yet to come actually. Because nowadays, one of the biggest challenges is that if you are designing an AI algorithm, what kind of hardware is supposed to support it? So this is a quite challenge. And this is the main reason that AI kind of algorithm I am saying, these are quietly parallel processing, or you can say that needs a lot of parallel processing, and your conventional hardware will definitely not able to cope up with this. So definitely you need a strong or a kind of robust hardware to be developed. So people are going on that direction these days. Over to you. If any other questions?
Yes, sir. I have two questions, sir. The
Yes,
first
yes.
question, actually, the last architecture you are using input video as well as
Audio.
sound. CNN is
Yes, yes.
working good for images, sir.
Yes.
Then for sound also you are giving some spectrum. I can able to understand the images, the wrong positioning of eye, nose, and the wrong posture that are considered
Yes.
as a fakes. But in a
Yes.
sound, we are giving only spectrum. What kind of features it will consider, sir? CNN.
Yeah, what exactly we are doing is we are trying to consider male spectrogram frequency. Actually, what exactly it's a time frequency analysis. Now, it happens that when a person is having a particular voice, so you can think of something like this, that may be possible that if I am having a background noise, and that background noise and some portion of the video, if it is paused, or it may be possible that the movement of face and the audio is not going to be matched. And that's why what we are doing is we are trying to merging the facial expression with the male spectrogram. So if there is a coherence, there's supposed to be coherence in everywhere, not in a particular time. Just think, if a person is lying, not supposed to blink much. Whereas its audio is going to be normal, whereas the person is crying. So person is giving an expression of crying, but its audio is completely flat. Now, case is, if you are going for a real video of it, you will find that when a person is crying, its audio will vary. But in a fake video, although person is giving a crying expression, its audio is supposed to be flat. You are not going for any frequency variation. So that part we are trying to say that there is a audio and video inconsistency there. And this is what exactly we are trying to detect.
Okay, sir. Thank you, sir. My second question is, sir, actually not from our topic. Actually, nowadays everyone using the research using deep learning, machine learning. But all the models were already predefined one. Everything is available inbuilt one. We are just giving an input and we are getting output. It really considers a research, sir.
No, actually, if you see what people are going now, they are going towards designing neuromorphic models. You might have heard of nowadays one new technology is coming as neuromorphic models. So what exactly it says that you are supposed to design the exact configuration of human brain, but definitely there is no way to say that human brain has these components, way it is analyzing. Now, how the conventional technology we can use to exactly follow the neuromorphic model of a human brain or a particular animal brain? Let us assume many people are saying that jackal is the one of the cleverest animal. Now, whether we can implement the brain of jackals. So that direction people are going, where they're trying to go for, let us assume, conventional CNN you are using. The CNN algorithm is modified in that way so that it will behave like a jackal's brain. So this is a kind of, you can say, explainability in AI content. So that direction people are going. Definitely use of some kind of algorithm is going to be tie up. But definitely many algorithms also you can design, or new algorithms you can design, which will say that this is a kind of landmark algorithm for some specific task. So that is also possible. So one way is that you are designing a new algorithm, kind of resonate, or you can say, I am designing a resonate algorithm. So that can be one contribution. Or you can say that you are designing different neuromorphic models for designing different algorithms. Over to you.
Thank you, sir. Okay, it's a time to say vote of thanks. Any questions? Audience, any questions from your side? Shall we wind up the session, sir, by giving vote of thanks?
Sure. Please.
Thank you, sir. Good evening, everyone. On behalf of the Department of Computer Science Engineering at SRM Institute of Science and Technology, I would like to extend my heartfelt gratitude to our distinguished resource person for today's session on focusing on fraud detection using deep learning. We are deeply appreciative of the valuable insight shared with us during this session. The depth of knowledge and practical application discussed have undoubtedly enriched our understanding of how deep learning can be effectively utilized to tackle fraud in various industries and real-time scenarios. The real-world example presented were particularly enlightening and will be beneficial to us as we explore new avenues in AI and machine learning. I would also like to express my sincere thanks to all the participants for your active engagement and thoughtful questions which have contributed to the success of this session. Your enthusiasm and eagerness to learn are what truly make this session meaningful. A special thanks goes to the AICT for their support in organizing this faculty development program, as well as to SRM Institute of Science and Technology for providing this platform for knowledge sharing and professional growth. Finally, I would like to express our deepest gratitude to our resource person for taking the time to join us this evening and share their expertise. We look forward to continuing this journey of learning and collaboration in the future. Thank you once again, sir, and I wish everyone all the best in your academic and professional endeavors. You spent a long time with us, sir. Thank you so much, sir.
Thank you. Thanks a lot.
Thank you so much, sir. Thank you, sir. Dear participants, once again, thank you all for your active participation in today's session. Tomorrow, we are having two more experts, Dr. Lipo Wang, Associate Professor, School of Electrical and Electronic Engineering from Nanyang Technological University, Singapore, and Mr. Srinivas Tota, Senior Vice President, Kumaran System, Chennai. Then we will meet 6 p.m. tomorrow for day 4 of this faculty development.